So you start.
Okay. Good evening to everybody, all the panelists, and Mr. President IEI, Vice President IEI, Chairman West Bengal State Center, and our panelists, and our attendees who are in this online webinar. I request Chairman West Bengal State Center IEI, Dr. Nirmal Das, to give his welcome address.
Good evening and welcome you all. In fact, by this time already 34 attendants are already joined. I hope it will be increasing further. Well, today Dr. Hemant Thakre ji, our President of Institute of Engineers, Engineer Sandeep Kumar Dev ji, Vice President of Institute of Engineers, Dr. G. Ranganathan, Chairman CATE, Professor Dr. G.S. Mundada, Chairman Electronics and Telecommunication Division Board, Engineer Chanchal Chakraborty, Convener of the Division, Dr. Raju Bosak, Honorary Secretary, and Engineer Ramchandra Chakraborty, Joint Honorary Secretary of West Bengal State Center. Panelist speakers, Mr. Shoibal Ghosh, Security Lead and Principal Solution Architect, Ericsson India Limited, Mr. Indrajit Nandi, IT Architect, Ericsson India Limited, past and present council members of the institution, distinguished corporate members, ladies and gentlemen. It is indeed my great pleasure, honor to be speaking here today and to welcome you. Being the chairman of West Bengal State Center, it is my privilege to address the gathering of eminent engineers and technologists today. On this occasion, let me extend my warm welcome to you all and especially our panel speakers, corporate members, distinguished guests, the staff of IEI, and my beloved students and other dignitaries. The theme of today's webinar is Amazon Web Services, AWS, and cloud computing. The worldwide pandemic situation we have since a couple of years forces us to enter in the digital life, as you know, where cloud computing is on the demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and services, we can access technology services such as computing power, storage, databases, and as on needed base from a cloud provider like Amazon Web Services. Amazon Web Services, or AWS, is a comprehensive, easy-to-use computer platform offered by Amazon. The platform is developed with a combination of infrastructure as a service, platform as a service, and packaged software as a service offering. It is a platform that offers flexible, reliable, scalable, easy-to-use, and cost-effective cloud computing solutions. A recent white paper survey by IDC shows that customers that migrate to AWS can experience 51% reduced cost of operation, 62% increased IT staff productivity, and 94% reductions in downtime. Today, we have a good number of panelists who are distinguished pillars in the field. Let us educate ourselves on the theme and explore how this digital technology can help us in our digital and comfort living. Thank you once again, sir.
Thank you, Mr. Chairman, for addressing the gathering. Now, I will say a few sentences about the theme. This evening, we'll be discussing Amazon Web Services and cloud computing. Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, we can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider. There are many cloud providers. Amazon is one of the most popular. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. With the cloud, we can expand to new geographic regions and deploy globally in minutes. For example, AWS has infrastructure all over the world, so we can deploy our application in multiple physical locations with just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. AWS has more services and more features than any other cloud provider, including compute, storage, databases, networking, data lakes, and analytics, machine learning and artificial intelligence, IoT, and security, etc. A recent white paper by IDC shows the customers that migrate to AWS can experience 51% reduced cost of operation, 62% increased IT staff productivity, and 94% reduction in downtime. May I request now, I have not seen Mr. Mundada on the, no, Mr. Mundada is not there, and Mr. Ranganath is also not there. So may I request now our II Vice President, Mr. Sandeep Kumar Dev, to address the audience.
Good evening. It's my proud privilege to have the chance to speak in front of my Honorable President, Dr. Hemant Thackeray of Institution of Engineers India. Well, this is creating a history that our President, even in such an evening lecture, is trying to be present. And mostly he is present in all these evening lectures, although these are not very big programs. So thank you very much, President Sir, for your kind presence to encourage the participants, the panelists, and of course, the organizer of this program. Well, Dr. Nirmal Das is creating a very good platform for the members to interact by providing this type of wonderful topic presentation by the West Bengal State Center. Amazon Web Services, AWS and Cloud Computing is a presentation by the Electronics and Telecommunication Engineering Division of the West Bengal State Center. Well, we have two pillars of West Bengal State Center from the Electronics and Telecommunication Engineering Division. One is now becomes our Joint Secretary, Engineer Ramchandra Chakraborty, and other one who is taking a huge endeavor to organize this type of wonderful program is none other than Mr. Chanchal Chakraborty, the convener of the Electronics and Telecommunication Engineering Division for this session of West Bengal State Center. Well, almost in every program I used to see the chairman of CATE, Dr. G. Ranganath. I believe that within a few minutes he will also join, because in the afternoon at 1 o'clock we had another program which is an ICC program, interdisciplinary committee program, where Dr. Ranganath was present. I believe that he will also join, and we'll be having Professor Dr. Girish Mundra, the chairman of Electronics and Telecommunication Division, very soon in this program. Well, it is by the endeavor of our entire team of West Bengal, we have been able to get the eminent speakers like Mr. Shoibal Ghosh and Mr. Indrajit Nandi from Ericsson India Limited. Well, I do not, I frankly speaking, I know very, very little, rather nothing about this Amazon Web Service and cloud computing. So like all other viewers here, I am also eagerly waiting to listen from them. So I am not going to tell anything more, rather than I will be interested to hear from my president about our institution and our activities. And finally, the eminent panelists will deliver on the AWS and cloud computing. Thank you once more for giving me a chance to speak in front of this August gathering. Thank you very much.
Thank you, Sandeep. May I now request our President, Dr. Hemant Onkarrao Thakre, to address the audience. And we are very happy to have him almost all our webinars. So nice of you, sir. Thank you very much from the core of my heart as a member of Electronics Division. Thank you for encouraging us.
Thank you. Good evening. Good evening, all. I always try to be present at not only in the West Bengal State Center, but other centers also. And particularly, it's my pleasure to be present in the functions of West Bengal State Center, from where my Vice President, Mr. Sandeep Dev, is also there. Vice President, Mr. Sandeep Dev, eminent panelist, Mr. Saibal Ghosh, Security Lead and Principal Solution Architect, Ericsson India Limited, Mr. Indrajit Nandi, IT Architect, Ericsson India Limited, Nirmal Das, Chairman of West Bengal State Center, Engineer Ramchandra Chakrabarti, Joint Secretary of West Bengal State Center, Engineer Chanchal Chakrabarti, Vice President, Technology, Reliance Jio, Professor Raju Basak, Honorary Secretary, West Bengal State Center, committee members of West Bengal State Centers, council members, staff from headquarters, and dear attendee. This is a great opportunity for all of us to be a part of this technical webinar on Amazon Web Services, AWS and Cloud Computing, being organized by the West Bengal State Center under the aegis of Electronics and Telecommunication Engineering Division Board. Over the last 100 years, the Institution of Engineers India has been dedicated to the service of the nation and to the engineering fraternity by providing valuable suggestions and recommendations to the policymakers of the country, which emanates from the discussions and deliberations from various technical seminars and conventions. During the pandemic situation due to COVID-19, when the world came to a screeching halt, I embarked on the virtual path to conduct webinar on contemporary and emerging topics for benefit of its members and engineering fraternity as a whole. Till date, IA has organized over 150 webinars on various topics pertaining to all branches of engineering. I am very happy that West Bengal State Center has taken a leading role in organizing webinar in emerging topics. The topic selected for today's webinar is very interesting. The cloud is now obvious as the backend for all forms of computing, including the Internet of Things. Cloud security is now an inseparable part of the cybersecurity ecosystem. The revolution of cloud is throwing up new ways to organize compute, such as containerization and development operations. A fundamental understanding of the cloud is essential to realize that it potentially can offer, especially in the telecom world, most prominently, where cloud is viewed not only as a collection of technology, but also as an operational model or a business model. We are required to appreciate the governance and enterprises risk management in the cloud and how it fundamentally alters our ways of doing business and the new challenges and opportunities it brings to the table. Key technologies are becoming intertwined with the cloud. For example, software-defined networks, containers, big data, Internet of Things, serverless computing are now spoken of in the same breath as cloud computing. In the foreseeable future, we will most definitely see and experience an explosion in the use of cloud computing, given its massive storage capabilities and elasticity, and the nurturing of microservices and cloud networking architectures. AWS, that is Amazon Web Services, is an application which uses cloud computing platform provided by the Amazon that includes a mixture of infrastructure as a service, that is IaaS, platform as a service, that is PaaS, and package software as a service, that is SaaS offerings. AWS service can offer an organization tools such as computer power, database storage, and content delivery services. There are more other services like Microsoft Azure, Google Cloud Platform, IBM Cloud, Oracle Cloud Infrastructure Generation 2, VMware Cloud on AWS, Alibaba Cloud International, vCloud AirPod by OVH, Tencent Cloud International. These can also provide similar services like AWS. I hope the eminent speakers present today will enlighten us further regarding the application of cloud computing in business process and in our daily life. I wish this webinar a grand success. Thanking you. Thanks all.
Thank you, Mr. President, for your kind address. We will now go for panel discussion. We have two eminent panelists. Sorry, from Ericsson. First panelist, Shoaib Ghosh. He is currently a security lead cum principal architect in Ericsson India Limited. He has an overall experience of more than 23 years in different areas of technology, including cloud security, Docker, Kubernetes, databases, and operating systems. He has numerous industry and vendor neutral certification around cloud security, database, and cyber security. He uses his understanding of technology to solve real world problems by matching technology with business requirements. He is very deeply involved in architecting secure and workable solutions for global customers and spends a lot of his working on nuances of architecture and security of the different telecom systems being deployed at the customer locations. He is well experienced in areas like security, solutioning, system integration, and consulting. He obsesses about technology and technical communication and works painstakingly to ensure that technical communication with various stakeholders are precise, correct, and meaningful. Outside of his work, he likes to spend time with his family as well as pursue his deep and abiding interest in yoga and meditation. Welcome, Mr. Shoaib Ghosh. Now I introduce our panelist number 2, Mr. Indrajit Nandi. Indrajit Nandi is an IT architect with over 17 years of experience in the mobile telecommunication industry. He is a TOGAF certified platform architect and documented success in creating IT infrastructures in the private and public cloud environment. He is experienced in areas like system integration, solution architecting, consulting in large-scale transformation, integration, and implementation engagement with leading global organizations. He has expertise in IT infrastructure, BSS implementation, business continuity setup, vendor management, etc. Now, the panel discussion will be moderated by Chanchal Chakraborty. He is Vice President Technology, Reliance Jio, and he is the convener of Electronics and Telecoms Engineering Division, West Bengal State Center, IEI. Chanchal did his BE and MBA and more than 35 years of professional experience in telecom and IT. He worked with flagship companies like CSC, NTPC, DOT, and DSNL, Aircel, Uninor, and Reliance Jio. Presently, Vice President Technology of Reliance Jio. He has wide experience in planning, design, procurement, installation, and maintenance in all fields of telecom. He participated in several national and international seminars, including GSM Congress at Cannes, France, and Berg for international roaming. He has received different accolades, including Vishish Sanchar Seva Award from the Ministry of Communication, professionally associated with IEI India as a fellow of the institute, and ISA USA. A team player and loves to serve society to the best of his ability. So here is panel discussion will start. Chanchal, please take over, moderate the session with Shoaib and Indrajit.
Thank you, Ramda. We will now start our panel discussion today. We'll request Mr. Shoaib Ghosh and Indrajit Nandi to join in the panel discussion and to start their presentation. Shoaib will be telling first what are the basic facets of the cloud, and then he will elaborate the basic features of AWS, and he will be giving some hands-on demo on AWS to make the idea clear. Now over to Shoaib and Indrajit to take over.
Thank you, sir, and good evening, everyone. It's an honor and a pleasure to present in front of such a distinguished audience, and both Indrajit and I appreciate the opportunity to present here. So today's discussion, as we are aware, is about cloud computing and AWS. And the way we have structured this presentation is that we are going to first touch on the basics of cloud computing so that we are all on the same page, and then we lead into the AWS fundamentals. We see how AWS actually structures out their cloud, and then once Indrajit has explained the basic features of AWS, I will take over to do some hands-on demo. So let me start the sharing the screen, and give me a moment before I switch on the video.
In between, I take this opportunity to announce that Saibal is the author of one book on cloud computing itself.
Actually, it's on Docker.
Yes, Docker and containers, right?
Yeah. So is my screen visible?
Yes.
Yeah, absolutely. Carry on.
Okay. So I will start with the basics, which is like, what exactly is the cloud? So many people describe cloud in different ways. People talk about cloud that it's a mechanism to rent out servers, compute, storage, and other things. But there has been some standardization over the years on the definition, and basically a cloud, which I will tell you, has certain attributes. So you can think of a cloud, if I move to the next slide, will have these 5 attributes. So broad network access is one of the main attributes of a cloud. So you should be able to access the cloud through network. The resources are pooled. So typically that translates as resources being pooled through a mechanism of virtualization, where the servers are actually carved out into different operating systems and different computes and storage, so that they can be given to the customers. Another facet of a cloud is a rapid elasticity, which means that a cloud, to be a cloud, has to give the customer that facility that they can scale in and scale out, which means that whenever they require more servers, they should be able to get them with a mouse click. And when they need to give away the servers, they should be able to do so as easily. The other aspect of it is that it's an on-demand self-service, which means aside from the elasticity that is going to be there, it should be on demand whenever they require it. For example, typical use cases are telecom vendors require a lot more compute, storage, and power during the times of, say, a festival, where a lot more messages are going back and forth. So for that period, they should be able to provision more servers, more storage, more network, more bandwidth. So this is something that is a very, very big attribute of cloud computing. And finally, there is measured service. There should be a mechanism to meter, because otherwise the customers cannot be charged. So if all these 5 attributes are there, then we call that a cloud. In other words, if we just rent out servers without having all the 5 facets, then that's not a cloud. So Cloud Security Alliance, an organization that standardizes a lot of things relating to cloud, has ensured that this is the definition that is followed by everyone. So now the question is, once we understand what is a cloud, what are the benefits of moving to a cloud? Why should I go to a cloud? That's a big question, because typically I have heard people say that moving to a cloud entails a lot of risks, security risks. Why should I move my data to the cloud? Who is going to take care of the cloud? So I will deal in brief with those things, but first let me discuss what are the benefits of moving to the cloud. The first benefit is you have flexibility of having as much or as little of the IT infrastructure as circumstances may dictate. And that's what I told a while ago. Then there's a reliability, because typically if you talk about the big cloud vendors like AWS, Google, or Microsoft, Oracle, these vendors take a lot of pain to see that their business model is such that it doesn't go down. It's reliable. They actually build that reliability, because their entire business is dependent on how much reliable they are. So that is an important point, that if you are moving to the cloud, you have reliability embedded in it. The third factor, and probably one of the biggest factors for moving to the cloud, is cost saving. Think of a situation where you are actually building a data center. So when you build a data center, there's a lot of investment that you do in the data center, not only at the initial stage, but there also is a maintenance of the data center. You have to run an entire IT ecosystem around that data center. So that's a capital expenditure. You now do not have to maintain a data center at all. All you do is you actually pay the rent, and you rent the servers, you rent the network, you rent applications, you rent the platform, you rent the database. So it's all operating expenses. So think of the savings that entails if you are using a OPEX model versus using a CAPEX model. Now, in the CAPEX model also, think of it like you usually over provision, because you are provisioning for the time when you will have the peak loads. So let's say you have the peak loads for 10 or 15 days a year. Then what about the time when there is no peak load? The entire computing capacity is going to waste. So that way you are always going to be, it's a losing battle, because you will never be able to provision for the average. You will need to provide for the peak loads. So this is an important point, an important decision point to move to the cloud. Further, if there's an ease of access, so any cloud like AWS, which we will be showing down the line, or Google or Microsoft, they all give you that ease of access. I mean, there's a couple of mouse clicks and you're on the cloud. Aside from that, the cost is very less compared to what would have been there if you were actually building your data center, because there's an economy of scale. When cloud providers run hundreds of servers in their data centers spread across the globe, they get the benefits of economies of scale. They build secure systems. They're able to leverage a lot of things that come with the scale that at which they operate. And finally, there's a benefit that you don't have to wait for provisioning till tomorrow. You get it instant. This instant access is a very important criteria for moving to the cloud. I can talk of many companies who don't own a single piece of hardware or even software, but they do an enormous amount of business simply from the cloud. Netflix is a case in point. They have nothing. They have no hardware. They own no software. They use the bare minimum applications. Everything they run is run from the cloud. So let's move to slightly more theoretical stuff before we go to the AWS part. I will talk a little about the cloud service models. So everyone has heard of infrastructure as a service, platform as a service, and software as a service, but probably I will be explaining a little bit here what they mean. So infrastructure as a service, if you talk about it, and most cloud providers started out with infrastructure as a service, is the provisioning of network, compute, and storage. So typically, even with AWS, what had happened is that they had started as an online bookstore, and then they realized that there were lots of servers that they were using, which they could probably rent out. But then there were a lot of other issues that came up, and then they built a model in which actually translated into the infrastructure as a service model, which means, in other words, it was not merely renting it out. It also included the other attributes that I just talked about a while ago. So infrastructure as a service is basically the entire infrastructure, which means the physical servers, the network, the compute, the storage, the virtualization, all goes in the IaaS part. The platform as a service, I can give you a small example. Suppose you run a database like Oracle, then that's a platform. The OS and the database or the data stores that you have are basically the platform. So many cloud providers will happily give you the platform. For example, AWS has a choice of databases. It has 6 or 7 databases that it can give you. You can run Oracle, you can run SQL Server, you can run MongoDB, you can run Redis, you can run Memcache. So there's a whole lot of databases. So think of the situation where you are not tied to a particular database. You might have some applications that would want some kind of a database, for example, a NoSQL database. While there could be other applications which are better suited for a relational database. In those cases, you would have had to pay license cost for 2 different types of database. But with AWS or Google Cloud, you get these databases off the shelf. So that is platform as a service. Now let's go one level higher. Think of, let's say, MS Word. I don't have to pay license for a small application like MS Word, because Microsoft Azure provides that as an application, as a software, as a service. So there are thousands of applications that are provided as a service, which means we don't pay the license cost, we just pay for using them. And slowly these things have grown. So we now have serverless. In AWS, we have a lot of services which run serverless. So serverless means it's not that there's no server. Of course, there are servers. It's just that the customer isn't bothered about provisioning the servers. So there's just, for example, someone has to run a piece of code. The piece of code could be 500 lines of code. And I don't want to be bothered with provisioning a server or finding a platform to write that code. I just go to AWS and there's a function called Lambda, and I'll just use that. And Lambda will do its own provisioning. So I just have a place where I can write code and run it. So this sort of gives us the benefit of using any platform. In fact, the choice of platforms are so big that we are literally spoiled for choice. And AWS keeps on adding service every day. I mean, on an average, they add 2 to 3 services every day. So there's an incredible 7,000 plus services in AWS today. So we can understand how the cloud service model has grown. So now that question that I initially started about security in the cloud. So let's take a look at the next year. Who manages what in the cloud? And this is an interesting question, because basically, theoretically, it's a shared responsibility. I mean, certain responsibilities directly go to the cloud provider, certain responsibilities are of the customer, but overall, it's a shared responsibility. So if you look at the first picture, the IaaS, then you will see that the service provider manages the networking, the storage, the servers, and virtualization. And then the rest of it, from the OS upwards, is your responsibility. But having said that, the entire model is a shared responsibility model, which means that, let's say, you cannot, for example, run some application that corrupts the system right into the virtualization layer. So that understanding and that contracts are there, that they will use the platform in a way which is conducive to ensuring that the services are not impacted in any way. In platform as a service, you will see that the service provider is responsible for right from the networking to the runtime, which means they take care of OS, they take care of middleware, and they provide all the bells and whistles for the runtime, which means only the database is your responsibility and the applications running on top of it. In software as a service, you just pick up the application. I gave the example of MS Word. It could be much more complicated applications, CRM applications. It could be any other application that, say, Google provides or Microsoft provides.
Presentation mode chole jao na bhai, তাহলে স্ক্রিনটা একটু বড় লাগবে।
Yeah.
Thank you so much. আর লেখাগুলো বড় ছোট পড়া যাচ্ছিল না। Thank you.
Okay. Okay. Next, let's move to the deployment models in the cloud. So what happens is that because we are standardizing the Cloud Security Alliance is an organization that has taken the lead in standardizing the cloud. We have some clear notions about what is a public cloud, what is a private cloud, what is a community cloud, and what is a hybrid cloud. I will briefly touch upon each one of them. So let's start with a public cloud. A public cloud is a cloud in which anyone can provision IaaS, PaaS, or SaaS, and they have no control over who else is there on that public cloud. It's just public. I mean, just it's like a public bus or public transport that you use. It's public. You have no control who else will be using that. So this is basically what AWS is or what Oracle Cloud is. They are public clouds, but they also have private versions. For example, Oracle has a notion called, or rather, I shouldn't call it a notion. It's actually a mechanism where what they call cloud at customer, which is where they go and provision their server on the customer premises, because the customer may not be very comfortable putting the data on Oracle's data centers. So that's an example of a private cloud. So in private cloud, you generally control who else is there on that cloud. So it could be one organization or it could be a few other organizations, but in general, you are not sharing the server or the storage with another customer. In a community cloud, it's slightly different from a private cloud. It could be a set of people or customers with similar requirements who are sharing a set of servers. For example, let's say all the telecom providers are provided a certain kind of optimized servers, which they share. So that's a sort of community cloud. And hybrid cloud is a model that is something that is used a lot, where some of your more critical assets are kept on premises, while some of the other things like your backups, your archives, and a lot of your other data are moved to the cloud. So this is something very common because of regulatory requirements, you may not be able to move everything to the cloud. So in that case, part of it is there on premises, and then they have the comfort of moving the rest of the things to the cloud. And in this context, I would like to mention that AWS is great in providing this hybrid model, because in a hybrid model, AWS does provide a lot of infrastructure so that the data that is moved from your on-premises to the cloud is moved in such a secure way that the customer is not in any doubt that the data could be compromised in any way. So they build a lot of infrastructure. They have actually set up a lot of infrastructure all across the globe, which helps an organization to move to the hybrid cloud. So moving on, let's move to that. What are the typical cloud security risks? So obviously, this is a big area of concern, and I'm going to spend a little bit of time explaining this. So let me take a very basic example. Let's say if AWS was to go out of business tomorrow, or if they somehow didn't want to continue this business, what happens to our data? So there is a lot of standards that have been set up on how the data will be managed on the cloud. So for example, there is a risk of data loss. So what the cloud providers say is that we are not only storing your data in one availability zone, but we are storing it in different availability zones. Availability zone is a synonym for data center, which means even if you don't know it or don't say anything about it, the cloud provider typically replicates your data into 2 or 3 data centers. For example, when Indrajit will talk about the S3 bucket, which is a form of storage in AWS, let me tell you that it's not even very well known that it's stored in 3 data centers. Any file that is stored in S3 automatically gets replicated across 3 or more data centers. So that's one way that the cloud provider ensures that you do not lose the data. Now, there are data breaches that happen. Let's say some unknown third party has actually breached your data. That's a risk. So again, the cloud provider provides a lot of certifications to ensure that the customer knows that they are certified. When I say certified, they are Those certifications relates to audit of the cloud. Those relates to certain standards that are supposed to be followed. For example, US government has a standard called FedRAMP. So unless a cloud provider is certified on FedRAMP, they will not be able to get US government business. So AWS, Google, Oracle, all are certified on FedRAMP. Similarly, there is another standard called FISMA. So cloud providers also take that certification. So now when you have these certifications and you see that the cloud provider has done the diligence of taking these certifications, then you're sort of assured that those data breaches are something that probably will not happen on cloud. There is some security risk relating to probably not everything is known on the cloud. When you have all your infrastructure and applications at that scale, there could be pockets where you do not know how the data is being handled. And we have had incidents on the cloud, and all of the clouds there have been incidents. But obviously, those are few and very far between. So it's probably there's as much risk on your own data center as is there on the cloud. Now, some customers are a little apprehensive that the access management on the cloud may not be up to their liking. So that is also something that AWS, I know for sure, has taken care of. Also, customers say that, okay, I understand they've taken care of for all the third-party risks and all other things, but what about insider threats? What if some insider hacks into our systems and steals some valuable data? So again, what AWS does is that they ensure that no insider has access to their data in such a way that they can access the entire data set. So typically there is multi-factor authentication. So probably if one key is with the cloud provider, a second key would be with the customer. So it's not possible for the insider to just get into the data that way. So there are a lot of protections, but also there is a threat of malware infections, hijackings, because the technology, let's say, assume that the VMs are shared across customers. There could be some customers who are probably looking for a way to breach your storage and get into your storage. So those weaknesses are there. And obviously, some element of risk will always be there. But the point here is that I want to drive home is that a similar risk exists in your own data center. So basically what happens, and what the model that I see in the future would be that it will be a hybrid model where you will keep your most confidential data, like let us say your R&D data on premises, while you send all your other data on the cloud. So that kind of gives you the best of both worlds. So that is the way I see that risk will be mitigated. So as I started talking about this, depending on the organization's needs, I can talk about Ericsson here a little bit. Basically, Ericsson has a lot of R&D that it does, and it's definitely not put on the cloud. But our products are certified on the AWS cloud. For example, our BSS stack is certified now on AWS cloud. So we are working with the cloud by selling our products on the cloud, but we are probably not putting all our stuff on the cloud. We are putting some of our own stuff on the Oracle cloud. I know for sure was used previously in Sweden. Probably there are other plans which I am not aware of, but definitely cloud is being used to control the costs and to ensure that data which is not a critical risk is put on the cloud. So risk mitigation is something that is taken care of. I mean, most organizations will not completely be oblivious of the benefits of the cloud. They will try to see that how they can benefit from the cloud by thinking smartly of which data they can put on the cloud and which data they will keep on premises. But the cloud providers like AWS has given us a lot of reassurance that the kind of self-introspection they do and the kind of certifications that they have done, the kind of audits they do, that really gives that confidence to the customer that yes, they are even better prepared to handle the security risks than we are ourselves. So moving to the next slide, who are the top cloud providers? And this is an interesting question because most people know that Amazon Web Services are the top cloud provider, and they are the top cloud provider by quite some distance, because Microsoft, who is second, is quite some distance below them. They are followed by Google, Alibaba Cloud, then we have Oracle, which is in a different quadrant, and then IBM and Tencent Cloud. So basically, as the leader, you see Amazon Web Services without a shadow of doubt. So that is one of the reasons we wanted to share our understanding of AWS today. So let's move to the next. How AWS is structured. So this is an interesting point because for AWS, the globe is a set of regions. So they have actually launched 26 regions, and these regions are divided into availability zones. So availability zones are nothing but data centers. Then in some cases, they have local zones where, let's say they have an availability zone in New York, but most of their customers are probably about 500 miles away, then they will create a local zone there. So that is one important thing that AWS is doing. Then there are 25 wavelength zones. Wavelength zones are nothing but when AWS actually builds a center inside the telecom providers. For example, they could build, and they have done that. They have built one of their centers inside their T-Mobile data center, which means the telecom provider doesn't have to go outside of their data center to access Amazon. So basically, for very large customers, what AWS does is they provide those wavelength zones where they build a data center right inside your data center. And you get the benefit of not having to move outside of your data center to take advantage of AWS. Aside from that, they have 8 announced regions, 32 announced local zones, 2 more regions. They are serving 245 countries as of today, and they have 108 direct connect locations. Direct connect locations are centers which are built to move data from your premises to the cloud. So sometimes you will need special bandwidth, special sort of security. So they provide direct connect locations to do that. And they have 310 plus points of presence. Points of presence are nothing but edge locations. So think of a customer, say in Australia, accessing some data from USA, and the latency could really matter when the data comes from that far. So it will be traversing the entire network. So to ensure that the system remains performant and the customer doesn't face latency problems, AWS has created those edge locations which cache the data, which means, in other words, what it does is that the first time the customer has queried the data or pulled the data, it pulls it from the server. But next time when the customer asks for the same data, it's taken from the point of presence. So there's a point of presence near Australia. So if the customer or other customers pull data, so next time, third time, fourth time, and numerous other times, it will be taken from the cache and there will be no latency. So this they are doing, and I'm told that in the future they will be building at least another 200 more points of presence, which will act as edge locations. So that is how it's structured. And just to give you an example, at least 2 availability zones per region. So if you take this US East region, then there are 1, 2, 3, 4, 5 zones, 5 AZs or availability zones. And similarly in Asia Pacific region, they have 3 availability zones. This is a typical example of how it's structured. It's based basically on the number of customers they get from which region. Okay, finally, how AWS positions its cloud. In fact, AWS always goes to the customer and talks about the cloud. So how does AWS talk about it? So one of the things they say, of course, is you trade your capex for opex, which I had mentioned earlier. The second thing they talk about is increased speed and agility. So as I will show you on the hands-on, it's incredibly fast. Provisioning a server, getting an S3 bucket, moving things from one end of the globe to the other. These are incredibly fast. So also you benefit from massive economies of scale. So I want to add one point here. So in 2006, when AWS started, the cost of renting a server at that time was about 12.5 times more than what it is now. So this is one organization that is working very hard to bring down the cost. So actually, if you start using AWS, you will see that they calculate the cost. Suppose you have used, let's say, a server for 1 hour, the cost is calculated in cents, not even in dollars. So that's how cheap it is. The next point is that stop spending money on running and maintaining data centers. Of course, we know if we are on the cloud, we will probably remove the data center from the equation. We do not need to capacity plan, and that's a really big thing. This because capacity planning, you can never guess exactly what your IT requirements will be 5 years down the line. So that is also completely gone now. And you can go global in minutes. You can open an office in one corner of the earth and then another office in another corner of the earth, and you can do business from both the offices using the AWS cloud. So this is how AWS positions its cloud. So from this slide, I will let Indrajit explain, where he will be giving you an understanding of how the traditional infrastructure and Amazon Web Services differ. So Indrajit, if you can come in, and I will stop sharing, you can start sharing slides.
Yeah, thank you, Shepal. Let me share my screen. Hope is it visible, right?
Yeah, we can see it.
Indrajit, please make it in presentation mode.
Yes, yes. So as Soibal explained in a nutshell, what is cloud all about? What is the purpose of setting up a cloud, and why people should move from the private data center to cloud-based data centers? So let us look into this apple-to-apple comparison. So what we have in our private data centers, and if we want to move our applications towards Amazon Web Services based platform, so what are the options we have from the AWS? So start from the basic building block. So when we have a private data center, we set up a private data center, we need hardwares. Hardwares means storage, servers, power, cooling, networking, and then security. So all these things we have to procure physically into a place, and then we have to integrate those components to build a platform or build an infrastructure where our applications will be hosted. So with this Amazon Web Service paradigm, so a user doesn't need to procure all these components, which is supposed to procure in the private data center paradigm. Instead, it will choose different services which will correspond to those physical components. So for instance, for data, the servers, it can, in Amazon, we have alternatives are EC2 instances. Okay, so in private data centers, we have computing powers in terms of physical servers. In AWS, we have EC2 instances, which provides us the computing powers. and memory. Then storages in private data centers, we have different alternatives of varieties of storages, such as SAN storages, which is storage area networking, then NAS storages, network area storage, and then DAS, which is a direct attached storage. These are all different type of physical storage. Okay. But in AWS, instead of physical storage, the storage as a service will be provided. Okay, there are different storage services that are provided in the Amazon Oval services, like EBS, Amazon Block Services. This gives a basic block device data services for an application. Then Amazon EFS, which is an Elastic File System service. Amazon S3 is basically an object storage. I'll discuss what is an object storage is and how it is different from a block storage. Then Amazon RDS. Amazon RDS is a relational database system. So in private data center, we have to set up databases like from a different vendor, like Oracle, Postgres, and we have to procure hardware. We have to create the database instance on the top of that, configure that. We have to engage a database administrator to maintain those. So if we move our applications towards the public cloud, then all these things comes as a service. Okay, so you can in Amazon Web Services, it is called RDS or Relational Database Service. Then on a networking perspective, on our physical data centers, that it requires network connectivity, Ethernet connectivity between different servers. It needs routing and switching to transfer data between the servers. On a north and south basis, on an east-west traffic, it needs a different kind of a networking protocol to be maintained and configured. In AWS paradigm, we have a VPC concept that gives entire networking facilities which are required to set up a platform or infrastructure as a service. And then we have ELB, which is an elastic load balancer, which gives a load balancing capability for the applications. So with all these things, then again, we have a security to be implemented that comes with firewalls and ACLs, administrations of, your authorization and authentication administration. These things are needs in a private data center, whereas in Amazon Web Services, it would be security groups, which is a feature of Amazon Web Services, which restricts a different application to or restricts or allow communication between different applications or different components or different services between Amazon Web Services. Then we have network ACLs, and then we have AWS IAM. AWS IAM is basically a centralized authentication system which let a user to log into an AWS console and to access a particular service. You can control which user can access or what kind of services or what kind of administration it can perform. That can be controlled through that AWS IAM. Now, consider a basic tier 3 applications. I mean, the purpose of a cloud is basically a host and applications, correct? So we need compute, we need storage, we need databases to host our applications. Okay. So in private data center, we used to, as I mentioned, there are different physical components we have to procure, and then we have to set up the entire stack. On the contrary, in the Amazon, we have to option to choose different services which will provide those kind of data center features as a service. Like Amazon S3 is a service which provides a object storage. Now think about what is an object storage. Object storage is basically a placeholder where you can keep your data. Now, the thing is that irrespective of the nature of data, you can keep that data into an object storage. Okay, in object storage, you can keep unstructured data like a file, or it can be a music video, it can be an audio file, MP3, whatever be that. So any structured or unstructured data you can keep into the object storage without knowing the formation how the data would be stored into the object storage. And the object storage gives you facility to access that data as a URL. So you just when you keep your data inside an object storage, it will generate an URL. Whenever you want to access that data, you just use that URL and just access the same data from the object storage. So in our, we may be familiar of our Google Daily Drive. The Google Drive is an application which provided by the Google. This is basically an object database data. Okay, so when you keep data into the Google Drive, you see, we keep our photographs, we keep our videos, we keep a document there, and everything is stored in the same Google Drive. Okay, and whenever we are accessing or sharing the data, we just creating an URL of the data and we are sharing with our friends, or we are accessing it from the different devices. So this is an object storage, and Amazon object storage is called S3. Okay, as Saibal mentioned, when you keep a data into the S3 bucket, it will be replicated across different geographically separate data center of Amazon. Okay, so that the data will be redundant. So if any data center falls apart due to certain reason, certain failure, maybe geographic failures, or maybe certain other failures, technical failures, then data can be retrieved from the other available data sets. Okay. So this is Amazon. Then to host application, we need basically a OS, correct? It could be a Linux, it could be Windows, or it could be any different other variety of operating system which are required to host application. So Amazon comes with AMI, or Amazon Machine Image, which is basically I can think of it's an ISO, or it's an image of where the operating system and certain other softwares are bundled. So if some developer needs to Linux, or maybe SUSE Linux as an operating system for its application, for his application, then it can use. They have a specific MI on for the SUSE. If someone needs the Red Hat operating system for the application, then Amazon has a Red Hat operating system, a Red Hat AMI. So there are all the different flavors. Amazon has a marketplace. If you log into Amazon console, Amazon Web Service console, you'll see there is a marketplace where you have different variety of operating system or AMI available, and you can also customize any AMI. Correct? You start build an image with a base AMI, and then you make changes into that, and then after making changes, you can make that convert that as another customized AMI. So and use that for your application development or application launching. So all these things like when you have an operating system, now you need a compute, correct? You like in our laptop we have a CPU, we have memory, and then on the top of that we installed an operating system, and then the computer becomes useful for hosting certain application like Microsoft Word. So similarly in AWS, if you want to launch an application or to install an application, first you need to have some computing instance or some mechanism which will give you compute memory. EC2 is that service which provides a computing facility or computing engine to the applications. Okay, there an EC2 computing engine means like how we differentiate between different computing instance in terms of its specifications, like what kind of CPU it is having, what is the amount of memory it has, what is the amount of disk it has. Based on that, we differentiate between the different computing instance. Same way, Amazon Elastic Cloud Computing also provide different flavors of EC2 instance or different flavors computing instance. So, and based on that, you can the metering will change. As you increase your computing capability to more and more CPU and memory, demanding more and more CPU, the metering will change. Okay. So EC2 instance, you can think of a computer where you launch your application. So it will be AMI and EC2 combined provide a application instance where we can install our application or we can develop our applications. So EC2 doesn't comes with any persistent storage. It comes with a ephemeral storage. That means that storage, when you stop a computing machine, all its content goes. It is lost, and then when you just create it, it will be again a fresh in memory space will be created for that instance. So But when you install an application or you develop an application, we need a persistent storage. So where even if your compute is, deleted, even if your compute is shut down, okay, still your data should be retained into the storage. So Amazon Elastic Block Storage is one such option, which gives a block storage for a persistent data store. So we talked about two different kind of storage from AWS. One is this EBS or Elastic Block Storage. Another is object storage or S3. Okay. So there are another type of storage is that EFS, that is basically provide a file storage. So by the name, you can understand the block storage provides a block level of data store mechanism where the data storing happens. The operating system inside the AMI manages how the data will be stored into the EBS or block storage. EFS is actually a file storage. It's a kind of NFS or NAS storage where it has its own. It is basically a file store which will be mounted or which will be accessed by different EC2 instances to write the data inside. It is like writing some data into a file system. So it is a file data. And then object storage, as I explained, object storage is irrespective of data structure. You can store into the object storage, and you can using a HTTP or HTTPS URL, you can access and share the data from the object storage stores. Then with compute and store, and then we need a connectivity of this this virtual machines or EC2 instance to access our applications. Okay, so as in private data centers, we have to set up a router, switches, and we have to connect different computers to communicate with each other. Amazon Web Services provider has a concept called virtual private cloud, which is basically a network namespace you can think of, where we have where we have a big chunks of IP will be given to one who will be owning that VPC, and then that VPC or this chunk of IPs can be subdivided into small subnets or small spaces of networks, and then application EC2 instance can be attached to those subnets. Okay, like in our real life applications, in a real life data centers, what will happen? There are different applications resides on a different network segment, and then they use a routing on switches to communicate to each other. This will require for maybe there are different reasons for that. One is the security. Maybe your database should be secured, highest secured, and then your application server may not be secured at that. It will be internet facing. So there are different reasons behind that to keep the different application component into a different network segments or a subnet. In physical world, what we do, we create different subnets into our switching and routing devices, and then we attach our servers or server network interface accordingly to as per the application requirement. In AWS paradigm, we have as I mentioned, we have a VPC concept. In VPC, you will receive a chunk of IPs, and from that we create a multiple small subnets or group of IPs, and then we dedicate that subnet for a particular application or particular purpose. So see, so this is you can think of this is a VPC. VPC is a kind of a placeholder inside a region. As Saibal mentioned, region is basically entire. It has a multiple availability zone. Correct? Regions spread across the geographical locations. Under region, you have multiple availability zones. Correct? So multiple availability zones means that provide a redundancy of your infrastructure or application. So availability zones are different data centers. So when you create a VPC, basically VPC is basically a placeholder of IP or networking address, okay, or IP addresses. So you can see in this diagram, we have a VPC where the IP address is stack 16. So a lot of IP address can be found in this IP range. Now, what we can do, we can segregate this /16 into multiple smaller network chunks. So you can see in data center 1, we have created 10.10.1.0/24, which is a subset of this /16 network. Similarly, in data center 2, we created another subnet, which will have this is also part of this bigger subnet or VPC subnet. Okay. So again, within the same AZ, we can create another subnets, or for maybe for a different purpose. Maybe for application, we create another subnet. For database, we can create another subnet. Okay. So that is possible. So we can create multiple such subnets into our availability zones. So only one thing, the subnets cannot, VPC can cross across the AZ, but when you create a subnet can go across your AZ. So subnets are limited to a particular AZ. Okay. Okay, and inside this subnet, now see, we have created one subnet like 10.10.1.0/24 is the subnet. So we will have a 255 IP addresses in this subnet. Then we can use those IP address and attach that into our instance. Instance means our EC2 instance, or you can think of a virtual machines, which is used for hosting the application or developing the applications. Okay, similarly, we can create another machines here, and we having again an IP address from this range 10.10.2.0.24, and we have a mechanism that this instance can communicate with each other. Okay. So this is in a bigger picture, what are the different VPC components are there. So as I mentioned, VPC can spread across a region. VPC is a region level component. Okay, whereas AZs are limited to a particular data set. Okay, then even this is a region. Okay, region is this is a region. Okay, under VPC you have a region, and then under region VPC you can create multiple subnets. Okay, and this purpose of these subnets can be different. So you can have a public subnets. Public subnets means the IP addresses of these subnets, okay, can be somehow accessible from outside. Okay, so I mentioned somehow because there are certain additional things needs to be done so that the IPs of these subnets can be accessible from the outside world. And then it will be private subnet. Private subnets, you can think of, it cannot be accessed from the outside of the AWS. Okay. Now, what is the purpose of typically two different subnets? Now, if you can have a application server, as I mentioned, in it, we have to host our application in AWS platform. There's a purpose altogether for having an AWS cloud. Now, this public, where you have, this is a public subnet where you can keep your application servers, which will be accessed from outside. And then we have a private subnet where you keep your database, because database data are very secure and it should not be accessed outside your AWS environment. So it will be kept here. And then we have a network access list can be configured in front of this subnet so that we can control what are the IPs and ports will be allowed to access this subnet. This way you can allow the security features in the for this subnet. Okay. Then, as I mentioned, that if we have a multiple, how we bring high availability to our applications. Now, there are one way. So, if you see this diagram, now we can spin up two instances in two different AZ and keep the same application across this. Okay. Now, what will happen? Then these will be redundant into each other. Now, when outside someone will going to access this, then how will access, correct? So it could happen that it can come to some certain point in some place, and then if that place can distribute the traffic across these two instances, then we can easily achieve the high availability, correct? So even if this data center goes down, still the traffic can come to this data center one. Okay, or even if the data center one is not there, the traffic can come to this other data center, correct? So this is basically, this mechanism is called a load balancer. In AWS paradigm, it is called ELB, or elastic load balancer. So elastic load balancer has a feature when it can have the members who will be serving a particular service, and then when the request comes in from the outside world to the load balancer, then it will distribute to its member servers, which are basically our application servers. And then behind these application servers, we may have a database servers, which will have the data, and it will take the data from there. Now, between the database server, there are multiple ways we can have database, and in between we have replication between these databases. Or we can do what we can have a primary database, and another is a standby database. And what we'll do, all the application may access this database when this is active, And when this database is down, all applications can access from the other available database. Okay, and the data can be replicated across these databases. So Amazon, as we mentioned, the RDS is the database services which provides this service, and you can choose between the variety of databases such as Oracle, Postgres, or any such or different available databases which will provide you the data services. Okay. So as I mentioned, so load balancer is a mechanism which will distribute the incoming traffic from the client to different availability zones where we have application installed. Okay, so this way we can also load balance across AZ. We can achieve high availability at the same time we can achieve a scalability. So like scalability is mentioned, this is for in a private data center. It will happen if your incoming load increases. So then what will happen? You have to, if you have to two ways, you have to either horizontally scale up. That means you have to add more computers into your data center, or you have to vertically scale up. So you have to increase your CPU or memory into the same server. In AWS, you have both the options. But in auto scaling, they have a mechanism called auto scaling, where based on the incoming load or traffic volume, you can the member servers which is serving that traffic can be increased. Okay, and that can be increased automatically. This is called an auto scaling group. So auto scaling group means is you can think of a placeholder where we have maybe initially you have maybe 2 servers, and you can set a rule that if a certain load if some load increases certain percentage, maybe 50% load increases, then what will happen? Then they will spin up another 2 servers. Okay, so that can be that the traffic, and you have a load balancer in front, so that traffic can be distributed across these different servers. So auto scaling group basically a placeholder where inside that you have your EC2 instances running applications, and based on the demand, based on the traffic volume, these instances can be new instances can be added into the same group. So you can start with maybe 2. Then you can say, okay, if your load increases over 50%, another 2 new instances will be added automatically. And when the load again reduces by from 50%, then this new instance will be automatically scaled down. So this can be achieved in AWS, which is not possible in our private data center. So with this, we have this is the structure typically for a full-fledged application hosting. If you see that for the high availability, applications are stored across different availability zone 1 and availability zone 2. That means there are 2 different data centers, and across these 2 data centers, we create basically a group of EC2 instance under our auto scaling group. That means we create an auto scaling group where we spin up the EC2 instances, and based on the traffic volume, the EC2 instances can be spinned. The additional EC2 instance can be spinned up dynamically. Okay, and we keep a load balancer in front of the EC2 instances, which takes the incoming traffic and distribute it across the different EC2 instances, which in turn actually spread across the different AZs. And these EC2 instances, which are actually hosting applications, is communicate with the databases. There are different variety of databases are there, and databases, as I mentioned, you can see databases are kept on a private data set, a private subnet, so that nobody from external outside can communicate it. It cannot be communicated from outside. Only within AWS it can be communicated. This private data centers, they are subnets, and they have this replication in between. So even if this data center goes down, so what will happen? The data will be remain here. So data will be available here. So applications can come, the traffic can come here and then can go to this database, and it will continue. Okay. So this way, a typical application, a 3-tier application is hosted on AWS platform. With this, I end my presentation, and then we can take some questions later. Before that, Saibal will show you a hands-on demo and how it is being, how in real AWS, from a real AWS console, how it looks like, how the different services are configured. Okay, and how it, he can show you on a small hands-on demo. Yes, over to you, Saibal.
Thank you so much, Indrajit, and let me share the screen. You have to stop sharing in the group. Okay, let me start sharing. And so, give me a second. I'm trying to. Okay, is the screen visible?
Yes, visible. Carry on, Shaival.
Yeah, okay. So took me a minute to set this up. So basically what Indrajit mentioned about AWS and how things go. So that was the understanding. But when we actually do the hands-on, you will see it's very, very straightforward and very simple to set up. Okay. Basically, the idea that AWS propagates is that it should be so simple that even if people do not have that understanding of, say, networks, VPCs, CIDR blocks, and other things, they should be able to get an EC2 instance. Now, just to take a step back, what is an EC2 instance? It's basically a CPU. It's basically the full form is Elastic Compute Cloud. That's why it's called EC2. And I have got 3 EC2 instances running. So typically, if I click on this, it shows me the public IP address. Just a second. Yeah. It shows me the public IP address and it shows me the private IP address. It shows me the instance state. It shows me the host name and a lot of other things that's related to this instance. So this is typically something that we have running. Now, if I were to just copy this public instance, public IP address, open another screen. Let's see if I can open a new window. And just paste this. It's right. Paste it once more. You can see that we have got this, which actually gives us the information that it's coming from a particular instance, the IP address and other things about this. Now, fundamentally, what we have done is we have created a few instances and we are running those instances and because we have those instances, we can easily ensure that we can utilize those instances to run our applications. Now, let's go back to the screen one second. Okay, now if I go back to the instances, you will see I have 3 of them running and each one will have its own IP address. There will be a public IP address, there will be a private IP address, and I can connect to the instances directly by just clicking on connect. So if I do this and connect, I should be logged into that system. So I am logged into the system, and if I can do something like this, ping, say, google.com. I'm able to ping Google, which means that my system is working fine. So if I go back and show you, basically, I have 3 instances running, and these instances are doing what they are supposed to do, which is that they will be able to host our applications. Now, there are a couple of things that people think. So what does it take to launch an instance? How launching an instance, how long does it take? So I will launch an instance for you and show it. But before that, I want to show something that Indrajit was mentioning, that there's a load balancing that goes on. So if I go and show you, there will be a load balancer that I have created. And this load balancer will have a DNS, which I copy, and I will either open a new tab or I will paste it on a new window. Let me open a new window. Somehow with Zoom, I'm taking a little bit of time to open a new window. I paste it and I press enter. So it says IP from this address. Now, if I refresh this, you see a different IP address, which means I had three instances running. It's load balancing between those three. If I keep on refreshing the page, you will see that I'm load balancing amongst the three instances. So basically what Indrajit said in theory, that as connections come in, the load balancing at layer 7 happens. It's not only a failure prevention mechanism, but it is also a mechanism to improve your performance, because you don't send all the load to a single availability zone. You send it to different availability zones. So if I finish here. So now let me help you with understanding basically how we create an instance and how quickly we can launch an instance. So what is an instance? It's basically a CPU with some storage and other things attached to it, but that storage is ephemeral storage, which is there in instance. But when I create this instance, what I'm going to do is I'm going to add some actual block storage. Indrajit mentioned about block storage. So we are going to add some block storage, and adding that block storage to an instance while creating it on the fly, it will take me just a couple of minutes or so. So I go to launch instances, and we'll just opt out, go for the old experience, which makes it easier for everyone to understand. So here they give you a choice of what type of image you want to use. Indrajit mentioned about AMI or Amazon Machine Image. So that's basically a template, and you have a choice. Some of them are free tier, which means these are free to play around, and some there are numerous images. Some will be paid images. So for example, you can have a Red Hat Enterprise Linux 8 HVM with SSD volume type, and so on and so forth. So we will use a free tier one and just select on this. So once we select on this, this will be selected and will say, give me the chance to create a T2 micro. So this is AWS parlance. They use this kind of terminology. So this is mine. So next it says configure instance details. And please pay some attention here, because this is important. So how many instances I'm going to create? I'm just going to create one instances. So it tells me that they have a VPC here. So if I wanted to use the default VPC that is available with AWS for every region, I can use that. Or if I have created any VPC, I have a created VPC, so I'll use this. So once we create a VPC, then what happens is that we need to enable this. And we just need to go through the, I am not going through the full here, but I want to show you how to add storage. Now here you get the chance to add the storage, which means that you have a choice of either adding a general purpose solid state disk GP2 or GP3, or you have, even if you want even more fast storage, then you have IOPS SSD IO1. If you're not happy with that, you need around say 256,000 IOPS, then this is the, but then this will become chargeable, and there is some magnetic standard storage. So let's go with what is the default. Next, add tags. Tags is nothing but some kind of a, if you want, say for example, this instance will be a test instance, so I can add a key that test instance. And next you have to configure the security group. So basically what security group means, that how this instance will be accessed. So typically they give an SSH, but probably you can add a rule cell. Go ahead and say, for example, all the protocols are there. So I probably add HTTP, and I will add probably HTTPS as well. The protocols are added. I review and launch. Now I can see the whole thing. This is the instance type. How many vCPUs? What is the memory? What is the storage? It is elastic block storage. It gives me the protocols that I'm following, and then I go into launch. There is a key pair that needs to be provided, so that's already there, and I launch an instance. It took me less than 1 minute because I was explaining. It may have taken me a little bit more, but your instances are now launching. And if I go back and I said, so you can see that instance is currently being launched. So this is how easy it is. Now, basically, when I launch an instance, that means that I have some more compute power available with me along with the storage. So please remember that not only have I launched an instance, but I've also added the storage to it. So while Indrajit was talking about VPC, it may have sounded a little complicated because there were so many things, CIDR blocks to take care of. For example, he explained how the instance is created out of those major, the main CIDR block from the IP addresses are actually carved out of the main CIDR block. So those things, if someone understands the entire networking protocol, it's great, easy. But if someone doesn't understand it, then in that case, AWS says, okay, we have automated everything. So let's create a VPC, and you will be able to see how easy it is to create this VPC. So just run to create a VPC. I go to the console. This is the VPC console. There is already 2 running in this region, but I'll create a third one. And I just click on create VPC. And it asks me, do you want to create a VPC or VPC with subnets? So I say subnets, and what it does, it auto-populates the whole thing, which means this CIDR block, CIDR stands for classless interdomain routing. So this block, what the IP address would be, I don't have to calculate. I may not be knowing all of it. I may not have that wherewithal to calculate all the IP addresses. So now it's automatically how many availability zones, how many public subnets, how many private subnets. Do you want to create a NAT gateway? If yes, then you can click here. But since this is a paid service, I'll keep it at none. Do you want to create an S3 gateway inside the VPC? I will keep the default, and I'll say create VPC. And I'll show you how quickly the VPC gets created. And it's done. I think we did it in seconds. All that Indrajit explained, I mean, what AWS has done is they have abstracted this thing. Now what I can do is I can create an instance inside this VPC, and we can load balance that just as I did for the rest of the instances, and we are good to go. I mean, after this, we can obviously host our applications on this. So just to sum up, what I showed you first was I had kept 3 instances running, and I had created a load balancer, and I load balanced those instances using that load balancer. Then I created a 4th instance, but because there is some more tweaking that needs to be done before it is added in the list of load balancer, which means that it becomes a target for the load balancer. I didn't do that here, but that's also trivial, which means that you can add an instance, and then that instance becomes part of the target of the load balancer. So if you have added 3 more instances, you would have 6 instances, and the load balancer, this is a layer 7 load balancer, it would have done the load balancing. Additionally, if you want to do load balancing at layer 4, you have another load balancer called a network load balancer, which would do the trick for you. Also, the fact is that you can do the auto scaling, which we were talking about. So if I go back and show you, basically all you need to do is let's go back to that step from here. Let me do it from here. I just put EC2, so need to score. So you just create an auto scaling group and you put a name to it, and then you use a launch template. So basically what you do is you, in this launch template, you put whatever, I mean, the idea here is that the auto scaling group will create instances whenever there is a load on the number of instances. Say I have 3 instances, but during a time at night, the load increased, and I am aware of that, and that is why I want the number of instances to increase to 6. So this is the template where I put the information that I want the number of instances to go up to 6, which is the maximum number of instances. So what will happen? This will scale automatically while we do this. Now, fundamentally, the idea here is that auto scaling has number of trackers, which means CPU usage can be tracked, network latency can be tracked. It could be a particular day. For example, let's say on Christmas Day, there's going to be a lot more traffic. So I want the auto scaling group to ensure that there are more instances. So I can put scheduled scaling. So scheduled scaling would help us to get the number of instances on that particular day. So getting back here, so all you need to do is create this template, and then you're back to that, to creating the, you use this template, go back, and let's see if I have a template. Yeah, I have a test template, so I'll just put here name. I'll just put ESG, put a test template already created. I'll just click next. So it asks us with which VPC you want to associate it. So let's say I have this VPC, project VPC, with which I wanted this associated. Then it asks it in which availability zones you want it. So let's say let's say I put it in this zone and those zones. I can put any zones, number of zones, and then I just click on next. So I may have this launch template may have been an old one, so it didn't work, but basically you get the idea. So after you have done this, and once the ASG has been created, auto scaling group has been created, all you need to do is go and set the rules, and that's it. So what I'm trying to show you here is that it's trivial. It's very simple to create those things. It takes me less than half an hour to build an entire 3-tier web application. And I'm saying this from experience that the 3-tier application that I built is very, very robust in as much that there is a redundancy which is inbuilt. So even if I have missed something, if something doesn't work, if one of the instances fails, or if there's something else that went wrong, we can easily create it. So this is one of the benefits of using AWS. They make it very easy. Let me show you how to create an S3 bucket. I just search for S3. I mean, even for someone starting out, it's trivial. It's so simple. Just click on S3. We are going to get some object storage, just as Indrajit talked about. We create bucket. Now, this is an interesting concept. This bucket name has to be globally unique, which means the bucket name, I put my bucket, and then I have to put some numbers so that it's globally unique. Nobody has done this. So just go down, scroll down, and create bucket. And you have successfully created the bucket. One of the questions in your mind could be, how much storage did I allocate? The answer is S3 is serverless. You don't bother about the storage. You keep on storing things. So the bucket has been created. So if you see this bucket, click on it, and you can upload files here. So you just click on add files. So if I have something on my desktop, let's see, I can add something from here. Okay, I have got picture here, and I'll just open add. So files gets added, I upload it, and it takes less than 5 seconds to get uploaded. So this is uploaded. I open this and I just click on open just to see the file. And there you go. We are seeing the file. So my fundamental point here is that it is so trivial, so easy to do this, that we can always do this very easily and keep on adding files. I mean, there's no limitation of space. I mean, think of it this way, that I can add 100 photographs, I can add an entire album, I can do anything. The interesting thing is that fetching is very fast in object storage, because in object storage, the metadata is also stored. So because the metadata is stored, the writing would be probably a little slower, but fetching would be very fast. So see how many options AWS gives you. You have block storage if you want very fast read and write. You have object storage if you want a huge amount of storage and you want very quick fetching. You are not bothered how fast it writes. So object storage is there. Then you have file storage. If you want a file hierarchy to be maintained and you want things to be kept in a file system, then you have EFS. So it gives you an incredible breadth of choices, which makes it so easy to understand and learn about it. Because as I said, you can build a 3-tier application so easily without even knowing the basics of, let's say, networking, not understanding. Indrajit may have talked about a lot of things. Many people may not understand what this /16 or /17 or /18 means. It's possible they may not understand. They may not want to bang their heads and try to understand from that main block how they can carve out the other blocks for the subnets. It's all automated. So just to sum up, I was able to show without without doing anything too much, how a load balancer works. I didn't actually create an auto-scaling group, but I guess you got the idea of how auto-scaling works. I created a few instances and showed you. I showed how S3 works, and that is all that's needed to set things up. Obviously, there are numerous services. So if I were to say, if you want to see the host of services, then you just need to, it includes analytics, it includes AR and VR, it includes blockchain. If you go down, you will see IoT, you will see robotics, you will see security. I mean, the host of services, these are the classes of it. For example, if you require developer tools, then you click on this and you see so many developer tools coming in. If you want to see IoT, just click on this and you see so many services there. So it's mind-boggling the kind of facilities and services that AWS provides. Any use case you have, there is something for you. So fundamentally, the idea here for this session was to tell you all that with AWS, cloud computing is just a few mouse clicks. It's not complicated. You don't have to understand everything to use the cloud. But yes, of course, if you are, for example, very deeply into blockchain and you want to do some research on blockchain using AWS, then of course you need to understand the service and how it functions. Also, security is very big in AWS. So they have a lot of things relating to security. Identity and access management is just one of the things. There are NACLs, that network access control list, and they have security groups. They have a complete, if I scroll down here, I can show you the security, identity, and compliance. They have a lot of things relating to security. So if someone is bothered about security, they have so many services to take help of. So basically, the understanding that I wanted to transmit is that not only is AWS something that is very much within reach, but also the fact that there is an incredible depth in the services they provide. I mean, and it's cheap. I mean, when I say cheap, I mean to say, think of if you wanted let's say developer tools, if I click, if you want all those developer tools and paid for it for this kind of quality and this kind of functionality, then you can just compare that and see that it's just no brainer that you should use AWS, because no other cloud provides. I mean, I've also worked with Google a little bit. Google is also very, very good, but I believe that AWS has much more functionalities, much more services to offer than Google. And that's one of the biggest reasons they are at the top. So on that note, I think I'm done with my part of the presentation. I believe I would like to take some questions. So if there are any questions, Indrajit and I would be happy to answer this. So I'll stop sharing, and if there are questions, I believe there will be some questions. So I'd like to give some time for answering those questions. Thank you.
Thanks, Shaibal and Indrajit. You have narrated the cloud services right from the beginning, how it got developed, the types of the services, and how the IaaS, PaaS, and SaaS work in the system, as well as you have elaborated about auto scaling and load balancing features, which are the fundamental thing in cloud. And you have elaborated about the AWS as one of the most rather prominent cloud service providers who are providing a bouquet of services and a single platform, which otherwise would have been a very, very costly solution if somebody wants to make on premises. As well as you have provided, told about how the service features as well as the security features built in that. And later on, the most thing is the important part that you have given a complete demo on AWS services, right from the creation of the instances, how the EC2 instances are getting created, and how the S3 instances are getting created. You have also told about the different kind of load balancers like L7 load balancers, as well as the network load balancer like L4 load balancers, as well as you have shown us how to make the auto scaling group and defining the rules that how it can operate. So these are the very important parts. And you have also narrated that the 3-tier web application can be made in less than half an hour. So these are the basic facets. And you have also told how the Amazon Web Service is spread across the different regions as well as the different availability zones to take care of the availability part. It's because sometimes what has happened, as well as because of some tsunami or some kind of natural disaster, some places are getting completely washed out. So nobody has to bother anything. The service will be provided by others. Otherwise, to make the DCDR kind of solutions, like this could have been a very, very costly one. And providing these type of solutions for all the small offices will be very, very difficult. Here, nothing to be done, only create an account and connect to the net and simply pay per use. So that is the model. I think everybody has understood about the basic facets. So many things could not be done because that we'll be organizing some other sessions where we can cover up the balance part, where we can how to club up the AR/VR kind of solution, IoT solutions, big data, blockchains, and like that how it can be. So the basic concept was to give a completely plethora of services and to give the entire gamut of solutions which can be provided by one cloud service provider. And you must be knowing that in 5G kind of telecom services, which is going to come, it's having the core network is completely based on the cloud, and as well as the radio access network part, that is the RAN part, is also cloud, and rather it has gone for the open RAN conditions. So this is very, very much important. The cloud computing has to be known, and it has been understood during the COVID regime that so many the operators and so many corporates have migrated their on-site premises data to the cloud environment, and maybe under the new normal situations, the majority of the corporates will be moving their solution from their on premises to the cloud. So the cloud is going to take a huge front role over here. Thank you very much for giving us a very illuminating talk on this particular topic, along with the demo, which has clarified the Amazon Web Services. Thanks, Shaival and Indrajit, collectively you have provided the hidden secrets and the inner solutions against this. Now I will invite the questions, and the questions have been several questions have come. Now, one question, some questions have already been answered, so that I am not touching up. One question has come: what is metadata and how the cloud storage capacity are calculated? It is asked by Mr. Shamal Ghosh. So I'll invite one of you to answer this question.
Yeah, okay, I will take this. Basically, S3 is serverless. So first, there is no reason for us to calculate because we don't need it. Secondly, even if we needed it, then object storage is such that the metadata that it stores will not be divulged to us. So basically, the fundamental concept with S3 is because it is serverless, and that is one of the USPs of S3, that we don't even need to calculate it. So for me, I would not even bother what the metadata it keeps, but what I know for a fact is because it keeps a lot of metadata. So when I query, let's say if I store just one picture that I showed you, if we store 100 pictures and I want let's say the 61st one, because it's a flat structure, it's not a hierarchical structure, it stores the metadata. That is why it is able to give me the data immediately. That fetching is very quick. So I hope that answers the question.
Yeah. Thanks, Aibal. Now, Mr. Satinder Chadha has told this is very interesting and informative session. So thanks, Mr. Chadha, for appreciating our report. And Mr. Salahuddin Pathiandra has asked the cost comparison with other similar cloud providers.
Okay, basically, when I have knowledge about Google Cloud, I'm not very sure about Microsoft, but when I did basic cost comparison, I would say that they were roughly same, but I would always put AWS ahead, because what AWS does as one of their basic principles is that they make things more performant and optimizes the cost. So what has happened, as I had mentioned earlier, since 2006, when AWS was launched, they have every year reduced the price of their services. So that means that I would think, I can guess that probably AWS is the cheapest of the lot. But Google, when I experimented with Google, I saw that Google also has a reasonable price. That's where the price war is between the top cloud providers. But AWS is ahead. I think it's the cheapest of the lot.
Okay. Thanks, Saibal. Mr. Manas Ranjan Mohanta has asked, what are the tools and techniques that you can use in AWS to identify if you are paying more than you should be, and how to correct it?
Okay, this is very interesting question, and I think I can give you a very good answer for this. Is that when I was playing around with AWS, I actually left some of the services running, and I ran up a pretty big bill. The AWS billing department is very prompt, because when they saw this was just testing that I was doing and not production, they immediately reversed the charge. So to answer the question, in the services, you will see one of the services is billing, AWS billing. So if you click on billing, it will show what are the services you have consumed, what is the bills against each service. For example, you have used S3, you have used EC2, you have used a load balancer, you have used a network load balancer, you have used a let's say elastic IP address, and so on and so forth. For each one, they segregate and give you the bill. So if If at any point you feel that the bill is probably not what it should be, then there is a very strong chat support system which gives you. So AWS is very, very prompt in that. So even if when people are playing around and they have left things on like I did, I have this empirical evidence where they reverse the charges. Yeah.
Okay. One anonymous attendee has asked, what is a DDoS attack and what services can minimize them?
Okay, DDoS stands for distributed denial of service, which is like when you have, let's say you're connecting to an instance and someone spoofs that, and you have say a sort of code that spins up a million connections, eating up the resources there. So this is basically a DDoS attack. So it slows down the system, it stops the system on its track. So this is an attack which happens mostly because someone is infiltrated your system. So one of the ways that we use, in fact, AWS has a lot of mechanisms, is using a web application firewall or WAF. You set up rules in the WAF that after a certain number of connections, no more connections will be accepted. So WAF stands in front of the VPC, so which means that any connection that goes into the VPC has to basically go through the WAF. So WAF is one mechanism. Then they have API gateways and other mechanisms through which the connections are filtered out so that a DDoS attack doesn't happen. So this is very common, and it's a good question because that's what AWS does. They suggest, in fact, they have another service called Shield. You can do a small Google search on AWS Shield. Shield is specifically built to prevent DDoS. Okay, so hope that answers your question.
Thanks, Saival. There is one more question by Mr. Satinder Chadha. I was told that in some web service price is based on usage, but in some minimum cost is to be paid. Can you please clarify?
Okay. Typically, most of the services are pay as you go, but there are some tools, some special services for which you are charged based. I mean, even when you have used it even once, or you basically have touched that service, there is a payment. These services are the ones that are probably more complicated services for which AWS thinks that it's not really required. But if you're requiring it, for example, I can recall there is something called Advanced Shield. So I just talked about Shield, which is a basic protection. But if you are going for Advanced Shield, there will be a cost for it. Regardless of how many DDoS attacks happens or doesn't happen, there is no way you can, I mean, basically you have to pay just because you use that service. So yeah, AWS has lots of services where you pay because you use that service. They don't calculate it based on the number of hours or any other metrics on that. Yeah, hopefully that answers the question.
Thanks, Saival. There is one question by Mr. Anirudra Prasad Yadav from Nepal. He is telling, thanks for informative and useful webinar. So thanks, Mr. Yadav, for giving his compliments to our speakers. One anonymous attendee has asked a question. As industries are going to be automated towards Industry 4.0, how cloud computing will help towards this?
Indrajit, do you want to take this?
Yeah, see, so it's all about automations, correct? So not only specific manufacturing industry or any other industries, all industries are leveraging or the automation for their benefits. Now, with AWS, the first and foremost benefit what you have, you are automating your data center itself. So if you want to host your application, you don't need to build a data center from the scratch. Rather, you have an automation. You can see how Saival demonstrated application platform can be spanned up so quick within few minutes. You can spin up your application platform and you can deploy your applications. And not only that, with the advantage of the internet, so you can suppose you have an industry where you have a automation services running, and that automation tools and tech can be hosted on the AWS itself, and it can be an AWS to your data center. AWS edge data centers are there, which can be hosted, co-located in the industry itself, in the specific industry premises, and using using the automated platform of the AWS, the industry automations tools can be hosted on the public cloud.
Right. Thanks, Indrajit.
Just
Is
a
there-
sec. If I want to add, industry 4.0 doesn't prohibit cloud computing. The part industry 4 is machine-to-machine communication, and for this communication, you can use cloud very well. So there is no contradiction between industry 4 and cloud.
Yes.
Okay, Chanchal.
Yeah. Is there any more question by anybody, from anybody? You can ask or can put the question in the chat box.
Chanchal, we have to look at the time also.
Yeah.
Hey,
I have
one
a-
last question you just take. Here is, I can see one question. You just
Anyway, so I think there is no more question.
one question is there.
Yeah, okay. What is the question?
You just read. Last one.
Acha, last one. Are Solaris and AIX operating systems available with AWS?
Probably not, because this AIX and Solaris both are basically proprietary hardware-driven OS. So there are specific CPU architecture required to host these operating systems. So when we talk about AWS, it's an open architecture. Intel architecture, x86-based operating systems are available. So these are proprietary, but probably I'm not sure if with special requests they can procure it, but normally these are not available. These are, as I mentioned, specific CPU architecture required to host this operating system. These are not Intel based.
Yeah, you are right, Indrajit. So since there is no more question, so I think now we can go for next portion. Ramda.
May I request now our Honorary Secretary, West Bengal State Center IEI, Professor Dr. Raju Bosak, to propose vote of thanks.
Am I audible?
Yes.
Hello.
Yeah, we can hear you. Please carry on.
Okay. Thank you. And actually, it is a customary, but I have to do the job. Anyhow, it is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical webinar on the theme Amazon Web Services and Cloud Computing, organized by the Electronics and Telecommunication Engineering Division of West Bengal State Center IEI through the online platform. At the outset, I convey my sincere thanks to panelist Mr. Shoibal Ghosh, Security Lead and Principal Solution Architect, Ericsson India Limited, Mr. Indrajit Nandi, IT Architect, Ericsson India Limited, and my sincere thanks also goes to my colleague, Dr. Nirmal Das, Chairman, West Bengal State Center IEI. My heartfelt thanks also goes to Dr. H.O. Thackeray, President IEI, Mr. Sandeep Kumar Dev, Vice President IEI, Professor Dr. Girish Srikishan Munda Dada, Chairman, Electronics and Telecommunication Engineering Division Board, IEI, and Dr. G. Ranganath, Chairman of CATE IEI. My heartfelt thanks also goes to Mr. Ramchandra Chakraborty, Joint Honorary Secretary of West Bengal State Center IEI, Mr. Chanchal Chakraborty, Vice President, Reliance Jio and Convener, Electronics and Telecommunication Engineering Divisional Board, West Bengal State Center IEI, and the moderator of this program. The same feeling is also being showered to all the members of the Council and Division Board of West Bengal State Center IEI. Last but not the least, my sincere thanks also goes to all who are behind the screen and giving their silent support in this technical webinar. Thank you very much.
Thus, we conclude our 11th consecutive monthly webinar session, and we look forward to have all the distinguished participants in our next webinar. I personally wish to thank our President, Dr. Hemant Onkar Rao Thackeray, for continuously attending the entire 2-hour session. Thank you very much, sir. Your presence gives us really encouragement. Thank you so much and have a nice evening. Thank you, sir. May you conclude the session, sir?
Yes, sir.
I
Yes,
now
sir.
close the session. Thank you so much.
Thank you.
Thank you. Thank you all.
Thank you.
Thanks, everyone.
Thank you, sir. With the permission of the chair, I am ending.